Find the coefficient of x in the polynomial p of x equals 1 plus x all to the power of n. Now 1 plus x all to the power of n in expanded form is identical to the binomial 1 plus x multiplied by itself n times. So there's n of these binomials. The expansion is a polynomial with n plus 1 terms. So 1 plus x all to the power of n is identical to 1. And we get that 1 by multiplying all the constant terms together, of course. 1 plus ax plus bx squared plus cx cubed plus dot 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 plus x to the power of n, where the coefficients a, b, c, d, and so on are positive integers. Now we want the value of a in the ax term, this term here. This is our focus because that's what the question is asking. It's asking for the coefficient of the term involving x. So it's this one here. Now in order to get that term in the expansion, we have n of these binomials. If we take the first binomial, choose the x, in order to get an x term, we multiply it by the constant term in all the other binomials. So, for example, our first choice would be to choose the x in the first binomial and then multiply it by 1 in all the other binomials. So x times 1 times 1 times 1 times 1 and so on will give us one of the terms involving x. However, there's another way that we can get an x term, which is by choosing 1 from the first binomial, choosing x from the second binomial, and then choosing the 1 term from the remaining binomials. So you end up with another term involving x, so 1 times x times 1 times 1 times 1 and so on. And this pattern can be repeated all the way to choosing the x in the last binomial, but then multiplying it by the 1 term, or the constant term, in all the other binomials. So what you end up with is ax is identical to x plus x plus x plus x and so on. And there are n lots of x terms, since 1 plus x to the power of n is the binomial 1 plus x multiplied by itself n times, and I've already said that. So this simplifies to ax is identical to nx, so therefore the coefficient of x is n.